Welcome back, students. In this video, we'll cover the different kinds of resistance arrangements. In the last video, we understood what is resistance, the resistivity, the property of resistivity, the factors on which the resistance depends upon. So in this chapter, we will cover how the resistance can be connected. There are two patterns of arrangements. One is arrangement in series, the other one is arrangement in parallel. And what are the key differences of this connection? Friends, this is a very important topic or a lesson which you can expect questions of a circuit diagram which is arranged in series or parallel. So please pay attention. So series arrangement. You have, let me explain the circuit diagram first. Whatever you see here is a battery containing two cells, and the longest plate is the positive. The current flows from here to negative. So you can see the direction of the uh, flow of current. So you need to mark in your drawings the arrow mark properly from positive to negative. This battery provides you the voltage V. Okay, there's an ammeter which is connected in series. Series means one after the other. So this is a symbol for resistance. Whatever you're seeing here, R1, that is the symbol for resistance. So you have a resistance R1 here. Immediately next to R1 is connected R2, and immediately next to R2 is R3, and you have a ammeter which is connected to measure the current that flows through this entire circuit. This is what the circuit diagram sees. Whenever a circuit diagram is presented, you should mentally run this flow or try to understand what is being connected, whether it is series or parallel, where the current flows from positive to negative, whether a ammeter is connected or whether a voltmeter is connected. Those kind of things you need to run through your mind. So in series arrangement, the resistance are connected in series, end to end. Means end of this R1 is connected to the other end of R2. So the key characteristics, the current flowing in such a circuit remains the same. Means whatever is the you provide 1.5 voltage or 3 voltage, whatever voltage you provide, and there is some current. The current passes through this circuit from positive to negative. So it is the same current which flows in the resistance R1, R2 and R3. That's what it says, same through all the resistors. But voltage is divided among resistors. Means the potential difference that is between R1, R2 and R3 are different. So the total voltage is sum of the voltage across the three resistances, V1 plus V2 plus V3, and the total resistance of the circuits. You just need to add the resistances. R is equal to R1 plus R2 plus R3. So how this is derived or how this comes, this we will understand bit more. We will revisit this topic when we discussed about Ohm's law. Ohm's law will help you to understand much more of how you are getting this V is equal to V1 plus V2 plus V3 and R is equal to R1 plus R2 plus R3. So we need to revisit this when we discuss the Ohm's law. One beauty of this arrangement is failure of one resistor leads to failure of all resistors. Means if R1 is not working, then the circuit breaks down. Means this R2 and R3 also does not work. So where this arrangement is required? This arrangement is required to increase the total resistance in a circuit, because the resistance is sum of all the individual values of the resistance. So R1 is 10, say R2 is another 10, R3 is another 10. So 10 plus 10 plus 10 gives you 30. So the series arrangement will help you to increase the resistance in the circuit. And another situation where do you need is another situation where the same current has to flow through all the resistances. So that is when you go for series arrangement. Now we will see the other pattern, that is the parallel arrangement. Here two or more resistors are connected to the same end. Means the positive end of this voltmeter is connected to this end of the resistance. Let me pick my pen. So positive is connected to one end of the resistance R1. The same positive is connected to R2, and same positive terminal is connected to R3 as well. So there are two or more resistors which are connected to the same end. Earlier it was end to end, now it is same end. See, the key characteristic is the voltage difference between all the resistors is same. Whether it is R1, R2 or R3, the potential difference or the voltage applied is the same across. And to measure the voltage, we have the voltmeter which is connected parallel. Remember in our chapter on voltmeter, we discussed that voltmeter is always connected parallel to the connection to which it is measured. Contrary to what we saw in series, here voltage is same, whereas current is divided among resistors. Means the current flow, a part of the current flow through R1, then another part of current, that I can call it as I1, then another part of the current flows through I2, and another part of the current flows through I3. So the total current that flows is a sum of I1 plus I2 plus I3, and the total resistance of the circuit is the sum of the inverse of the resistance values. That is, the total resistance 1 by R is equal to 1 plus R1, 1 by R1 plus 1 by R2 plus 1 by R3. The beauty of this pattern is the failure of R1, say for example R1 fails, that doesn't affect the voltage or current flow across the other two resistors. So where do we need this kind of arrangement? When we need to decrease the total resistance in the circuit. Because there is an inverse relationship, 1 by 10 is 0.1, 1 by 10 is 0.1, and similarly 10, 10, I am assuming 10 each, okay. 0.1, 0.1, 0.1, and you need to take inverse because it is R. So 0.3 inverse becomes 3.33. This is lesser than 10, and we'll mathematically see it in a while. So it is used to decrease the total resistance in the circuit, whereas in series pattern it was used to increase. Here it is to decrease. Another situation is we saw that failure of one resistor does not affect other resistors, meaning the other two resistors keep working. So in a scenario where you need the same voltage, and another situation is where you need the same voltage across all the components. So you have a situation where the same voltage has to go to resistance R1, R2 and R3. You cannot develop through a series circuit. You can develop only through a parallel arrangement. So let us quickly sum up the difference between both these connections. Series, it is connected end to end, whereas parallel it is connected to the same end. Current is same through all the resistors, whereas for parallel it is the sum of the current flowing through individual resistors. Voltage in series is the sum of the voltage through individual resistors, whereas for parallel it is the same. It is just a opposite, like between series and parallel connection, the current and the voltage behavior or pattern is just the opposite. In series the current is same, whereas in parallel the voltage is same. So you have to note the difference. The effective resistance in case of series is sum of all the individual resistances, whereas of parallel it is the sum of the inverses of the individual resistances. So what is the net effect of this arrangement is the total resistance is more than the highest resistance in the case of series. In case of parallel, it is the total resistance is less than the lowest resistance. In a minute, we will see mathematically what it means. So be with me till then. So the purpose of building a series arrangement is to increase the total resistance, whereas for parallel it is to decrease the total resistance. When one resistor fails, it affects all the resistors in case of series. In case of parallel, it does not affect other resistors. This table is very important. I request you to memorize it. This is very important. Please memorize this table. This will be a foundation for all the problems that you work out in this chapter. Most of the problems, not all, most of the problems around Ohm's law and circuit diagrams. So quickly we will see what is this highest resistance and less of lowest resistance. See, now consider two resistors. One has 10 ohms, other has 40 ohms. They are connected in series. When they are series, the total resistance 10 plus 40 is equal to 50. This 50 is greater than 10 as well as it is greater than 40. So that is the meaning of the series resistance being larger than the largest resistance of the two resistors. So that is the meaning. Now assume that this 10 and 40 are connected in parallel. So now the effective resistance is calculated by inverse, like 1 by R is equal to 1 by R1, that is 1 by 10 plus 1 by R2 is equal to 1 by 40. When you add both, you get 1 by 8. When 1 by R is equal to 1 by 8, R is equal to 8 ohms. This 8 ohms is lesser than the smallest resistance. This 8 is lesser than this lowest resistance 10. So that is the meaning when you connect in parallel, the effective resistance is lesser than the lowest resistance of the circuit. So we have covered most of the important topics. So the next video we will focus more on the board exams, covering all the board exam papers, sample papers, as well as your textbook problems covering all these topics. Thank you and bye till then.